Hey YouTubers, we are here with Owen, my 6th grader, and today we're talking about matter and energy from our study guide. Owen, can you read the first question, please?
Yes. What is matter?
Okay. What is matter?
Anything that has
Mass.
and takes up space.
Yes. So matter is anything. Anything. Okay? Anything that has mass and takes up space. Yes. And I got, just so you know, Owen has tape on his glasses and his bow tie on because he's a science nerd today for our science video. And he's really smart. Yes.
What is mass? A amount of matter in an object.
Yes. Mass. See how we put the M-A-S-S, how I made mass in dollar signs? So mass, those dollar signs mean amount. Mass is the amount of matter in an object.
How do weight and mass differ?
How do weight and mass differ is the question. Well, weight and mass differ because mass never changes and weight is based on gravity. So you might get on the scale one day and be 5 pounds more the next day because of what you have inside of you. So the mass, my size really didn't change that much from day to day, but the weight is based on gravity. Okay, number 4, please.
Can matter ever be lost?
Can matter ever be lost? Well, to answer that question, we have our little friend here. This is Matt, or his official name is Matter. And no, he never gets lost because he has his GPS on his cell phone. So matter never gets lost. Volume. Volume is like on our phone, we turn up the volume. Our last video didn't have very good volume. So on volume, we have the amount of space something takes up. So here's our volume, and you can see that the yellow takes up that much space in the volume.
Number 5.
Number 6.
Number 6. What is
Density.
density?
Oops. Density. I'm going to show you my little friend. Her name is Density, not Destiny. It's Density. And she says, my pants are too tight. My pants are too tight. So density is how tightly packed the particles in an object are. So density's pants are tightly packed.
Phases of matter.
There are 3 phases of matter. And Owen, let me find out. What are the 3 phases of matter?
Solid is solid. Liquid goes to water. Gas is, let me see it.
Yes. So we have solid, liquid, and gas. Those are our 3 things of matter.
How do the molecules act in a solid?
The molecules in a solid are tightly packed and barely moving. So here we have a solid suitcase, very solid. And the suitcase is the molecules, and it is tightly packed. Tightly packed suitcase. That's how they act in a solid.
How do the molecules
Molecules.
act in a liquid.
Okay. And how do molecules act in a liquid?
Alright.
And to show you, we have our slide. Here's our molecule going down the slide, and it's going down that slide fast, and it's going into the pool, which is a liquid. So molecules in a liquid, they slide very fast.
Let me say again.
Molecules.
Act in a gas.
Okay. So molecules in a gas, they are bouncing around quickly, moving very, very fast. So if they're bouncing around quickly, very, very fast, it's kind of like a fart coming out. So when you're thinking of gas and molecules moving very fast, they're quick and fast, just like a fart comes out.
What causes matter to move from state to state?
Okay. Matter moves from state to state. And why does it move from state to state, Owen?
Temperature.
Temperature, yes. So we see our matter moving from the state of Ohio, where it's stormy and rainy, to sunny Texas, where the temperature is a lot warmer.
Get an example of matter that moves between the three states and give an example of each.
Okay.
I know it.
So we're asking the question, give an example of matter that transfers between the three states, and give an example of each. So the examples would be like ice as a solid. Okay, we're talking about H2O, water. So in the solid form, it's ice. And then in the liquid form, it's water. And then in the vapor form, it's gas. So again, we're back to solid, liquid, and gas.
What is a
An atom. So what is an atom? I'm going to show you on my picture here of my friend. His name is Adam. See his little head and his eyes and his happy face. So atom is made up of four things. He's made up of the nucleus, and then he's got the neutron, the proton, and the electron. So we got the nucleus up here in his brain. We got neutron, which is neutral, proton, which is positive, and the electron, which is negative. Thank you, Adam.
What is energy?
What is energy? Yes. Energy, oops, I can barely read that. I scribbled over that, didn't I?
Yeah.
Energy is the ability to do work. Just like Owen has energy when he cleans the cafeteria at school, he has the ability to do work.
How do we measure energy?
We measure energy. The question is, how do we measure energy? We measure energy with joules. Aren't that pretty? Pretty joules.
What is thermal energy? Give in simple.
Okay. The question is, what is thermal energy? And give an example. This one's kind of complicated because, so I put my thermos in the fire, which is heat. And its energy, thermal energy is energy in the form of heat in the fire. And it's the fire is the example. So we got thermal, it's in the heat and fire. Chemical.
Change
Energy.
Give in simple.
Okay. Chemical energy is stored energy. An example would be food that our body uses for fuel. So we're thinking about chemical energy right here. Chemical energy. It's stored, and in the store we have food for fuel. So we got chemicals in the store, and we use it for food, which is fuel.
What is
Electromagnetic energy. Okay, electromagnetic energy is energy as an electromagnetic wave. So that could be like light, electricity, or light bulb. Now, Owen has a special hobby of magnet fishing, in which we throw the magnet, which would be our energy, or electromagnetic energy, into the waves, okay? And he actually collects a bunch of metal things, but it's electromagnetic energy is energy as, hang on, I lost my place when we did that, is energy as an electric magnetic wave, such as electricity and light.
What is
Nuclear
energy? Give an example.
Yes. Nuclear energy is energy created by splitting atoms. And the example would be a nuclear bomb. So here we got my friend Adam. Again, there's Adam. Remember Adam, we showed Adam before. But this time, he's going to split. He's getting out of here because there's a nuclear bomb. It'll blow up. So he's running away. And he's running away. We got two atoms here, actually, and they're splitting because of the nuclear bomb.
What is
Mechanical
energy? Give an example.
Okay. Mechanical energy is energy created by doing work to an object. So, for example, if we have a ball and we're throwing it, the mechanical energy would be the throwing of the ball, using your arm to throw the ball.
What is kinetic energy?
What is kinetic energy? Kinetic energy is energy in motion. And Owen has another hobby of building Connect roller coasters. And once he gets those roller coasters built, they are always in motion. They're super cool. They're super big. He's got about 5 of them and a Ferris wheel. So your Connect roller coasters is always moving. That's kinetic energy is always moving.
What is
Potential
energy?
Now, potential energy is stored energy. See, here's how this battery is just sitting there. The battery has energy in it, and it's just being stored for now until we use it. So, potential energy is stored energy. Now, the next section of things, it says, label each of the following as potential or kinetic energy. So, Owen, if a car was driving down the street, what kind of energy would that be?
Kinetic.
Yes, it would be kinetic, because the car is always moving. What about this? A carrot. Is the carrot moving?
No.
So what kind of energy would the carrot be? Potential. It's still potential.
Almost done.
And that we're almost done, YouTubers. That's right. Okay, so a sled is resting on the top of the hill. Potential, because the sled's not moving, it's just resting there.
A basketball getting thrown across the field. Kinetic.
Yeah, so basketball getting thrown across the field, it's kinetic because it's moving. What about a rock being held above your head? Is it Potential or kinetic?
Potential.
It's potential because it's not moving. It's just being held above your head.
A bow and arrow being
Pulled back.
Pulled back.
So a bow and arrow being pulled back, that one's a little bit tricky to me because you think that bow and arrow being pulled back is moving. But really, when you pull it back, it's still still. So it is potential.
Potential energy.
What about a campfire? What kind of energy is that?
Kinetic.
Kinetic. Because the fire is moving, right, Owen?
Yeah. And
An unlit candle.
current.
Potential. An unlit candle is a potential energy because it's not moving. It's just sitting there.
A windmill turning in the breeze.
Yes, a windmill turning in the breeze would be kinetic. Okay, that's it for our matter and energy study guide. What's that saying you say? If you like us, click the like button.
Click the like button and subscribe down here. And,
And ring the bell.
and ring the bell. And check there on Mommy's head. Is Mommy and me reading something about this?
Yes. And if we have 10 subscribers, we're going to have a party. Woohoo!
And
So signing off, this is Science Nerd Owen, signing out.
one more thing. Ashton needs to subscribe us too.
Ashton needs to subscribe us too. Okay, over and out.